Hey everyone, Felix here from InventBox, where the solution is right around the corner. In today's tutorial, as promised, we're going to talk about analog reading. Now, analog reading is very similar to digital reading in that we're just measuring the voltage that's on one of our pins. However, the difference is that analog reading has it has a much wider range than digital reading. Digital reading could only measure low or high, but analog read can measure all of these different places in between. It has a range from 0 to 1023, and that would just depend on the voltage. 0 volts, as we can see, would be an analog read 0, and then 5 volts would be an analog read 1023. If we did an analog read around here, it would be about 512. Maybe down here is about 120. So we can get all of these different steps on a digital or on an analog signal using the analog read. The analog pins on the Arduino are located down here, labeled with A's and numbers. These have what's called analog to digital converters on them, which means analog signals can come in and it converts it to digital so that the Arduino can process everything, but they do not have digital to analog converters, so we cannot output true analog signals from these pins. The best we can do is use the pulse width modulation pins that we looked at in the last video. So what we're going to do is hook up a knob in order to control the brightness of an LED. So here's a potentiometer, or pot for short. Here, this is the symbol for it. This is basically a knob that has 3 leads on it. If we hook up one of the leads, and it has a variable resistance in the middle. So if we hook up one of the leads to 5 volts and the other side to ground, look what happens when we turn the knob. We might start over here where this is called the wiper actually, where the wiper is touching the 5 volt side, and so the analog pin is going to end up reading 5 volts. If we turn it all the way to the other side, then we'll end up reading 0 volts. And then anywhere in the middle, we'll end up with some voltage value, and our analog pin is able to tell us pretty much exactly what voltage it's at, anywhere from the 0 to the 1023. So with that in mind, let's go ahead and build the circuit. Okay, so here is the potentiometer. As you can see, it is just a knob with 3 leads on it. And as per the schematic that I showed you, we're just going to hook up one side of that to the 5 volts, the other side to ground, and then the wiper gets hooked up to analog 0. And then I also just have the same LED from the PWM video hooked up with a 220 ohm resistor on pin 11, which is a PWM pin. So now let's get to coding. We're going to need to create a variable for our potentiometer, aka pot, and that is going to be on analog pin 0. And Arduino automatically makes the distinction. You don't have to worry about if you're on digital 0 or analog 0, because when you use analog or digital read, or analog read and write, it automatically just uses these pins down here. So just put 0 for the analog pin, and then we're going to need to, of course, initialize the pot as an input so we can use it as a control knob. Then let's read its value and save it into a variable called raw pot. The reason that I'm calling it raw pot is that this is actually not going to be able to plug straight into the analog write. What we need for analog write is a value between 0 and 255, but this analog read will give us 0 to 1023. So what are we going to do? Well, turns out that Arduino has a built-in function called map. That lets us take some value and compare it to two different ranges, its original range that it came from and a range that we want to transpose it to. Since this originally is from 0 to 1023, we want to make it go from 0 to 255. And so this map function will automatically map these values to these values so that everything corresponds properly and proportionally. And so we can assign this to something like mapped pot. And now we can put the mapped pot into the analog write because it has the correct range, 0 to 255. And we need to create these variables that we used. So we'll just define them up here. We just have raw pot and mapped pot. We don't need to give them values because they're being assigned down here. All right, well, that's it. So let's go ahead and try it. Upload. And there's our LED. So if I turn this, it gets brighter and dimmer depending on the position of the potentiometer, which is exactly what we want. So we have an analog signal between 0 and 5 volts somewhere being fed in, being read by the analog pin with the analog read, and then the Arduino translates that into a PWM signal so that we can dim the LED. Pretty nifty. Of course, you can use the analog read for much more than just volume control or potentiometers even. A lot of sensors that you'll find yourself using on the Arduino will have analog outputs. And so you can hook up these sensors to your analog pins on the Arduino and do all kinds of calculations and algorithms using your sensors. Now I think we've got a pretty good basis for all of how to use the pins on the Arduino. So in the next video, we're going to take a look at adding some more hardware to this through something called shields.